Hey there, and welcome to The Explainer. Today, we're going to crack the code on all those formulas you see everywhere. The ones that look like a confusing jumble of letters. Well, by the end of this, we're going to turn them into powerful, flexible tools that you can literally bend to your will.
You know the feeling, right? It happens to all of us. You're planning a trip, you look up the weather, and it says it's going to be, say, 25 degrees. So, is that shorts and a t-shirt weather, or do you need a sweater? It's a classic problem. You have the information, it's just in the wrong format for you.
I'm sure you've seen this one before, probably tucked away in a science class. It's the official, tried-and-true formula for converting a temperature from Fahrenheit over to Celsius. For our purposes, let's think of this as our first clue. And there it is. That's our big mystery. The formula is built to find Celsius when you already know Fahrenheit. But in our travel scenario, we have the Celsius when we need to figure out the Fahrenheit. The tool is designed to work in the exact opposite direction of what we need. So what on earth do we do? Well, the key to solving this whole thing is a concept called literal equations. Now, I know it sounds a little intimidating, but it's really just the official name for these kinds of formulas, the ones that have more than one variable floating around.
That's it. That's the whole definition. So that's C equals 5/9 F minus 32? Yep, that's a literal equation. It's got a C and an F. Any formula you can think of with a bunch of letters, like area equals length times width, or distance equals rate times time, they're all part of the same family.
Okay, so here's where we need to shift our thinking a little bit. With these literal equations, we're not trying to find a single number answer. Nope. Instead, our goal is to rewrite the equation, to completely rearrange it so that the variable we care about is all by itself on one side of the equal sign.
So if we're going to be detectives and rearrange all this evidence, what tools do we need? Well, the good news is we really only need one major tool in our detective's kit. And this is it. This is the fundamental #1 rule of pretty much all of algebra. It's the one principle that lets us manipulate and rearrange any equation we want without, breaking math. This right here is the golden rule. Seriously, think of an equation like a perfectly balanced scale. If you add 5 pounds to one side, you have to add the exact same 5 pounds to the other side to keep it from tipping over, right? It's the same for subtracting, multiplying, anything. This rule is the absolute key to cracking our case. All right, let's do this. We've got our clue, we've got our tool. It is time to solve this thing. We are going to apply the properties of equality step by step to get that F for Fahrenheit all by itself. Okay, so here's our starting point. The F that we want is kind of trapped inside those parentheses, and the whole thing is being multiplied by that fraction, 5/9. So our first logical move has got to be to get rid of that fraction. We need to undo that multiplication. So how do you undo multiplying by 5/9? Well, you do the opposite. You multiply by its reciprocal, which is just 9/5. And, of course, our golden rule. Whatever we do to one side, we have to do to the other. So we multiply both sides by 9/5. On the right side, the fractions cancel each other out. Poof! And on the left, we're left with 9/5 times C. And look at that. The F is almost free. We are so close. All that's left is this pesky -32 hanging out next to our F. To get rid of it, again, we just do the opposite. We add 32. But, you guessed it, we have to do it to both sides to keep everything balanced. And just like that, F is all by itself. We've done it. Case closed. And here's the really amazing part. We didn't just find an answer to one problem, we actually built a brand new tool. We now have a completely new formula that's designed to turn Celsius into Fahrenheit directly. So that 25 degrees Celsius from earlier, now you can just pop it into our new formula and know exactly what to wear. But this skill isn't just for telling you if you need a jacket or not. It's used all over the place in math. Let's look at another quick case, this time with linear equations. You can think of these different forms of a line as the same story, just told from different points of view. They're all just literal equations, and each one is arranged to show you a specific piece of the puzzle, like the slope or where the line hits an axis. Standard form, though, that one likes to keep its secrets hidden. Using the exact same skills we just mastered, isolating a variable, you can rearrange that standard form until it looks just like the general form. And the moment you do that, it instantly tells you the slope of the line. You're making the formula tell you the exact piece of information that you want to know. So what does this all really mean for you? It means you've just unlocked a brand new way of looking at pretty much any formula you ever come across again. And that's the real takeaway here. You're not stuck with a formula the way it's handed to you. You now understand the fundamental rule that lets you take it apart and put it back together in whatever way serves your purpose. You're in control.
It really all boils down to this one core skill: rewriting these literal equations by always keeping them balanced. It is one single key that unlocks an incredible number of doors in math, in physics, in finance, you name it. Anywhere there are formulas, you now have the key.
So think about it. The formula for the area of a circle, the one for simple interest, even good old distance equals rate times time. They are all just sitting there, waiting for you to decide which part of their story you want to hear first.